Hi everyone, today we're going to be learning about arithmetic sequences. An arithmetic sequence is a sequence created by addition or subtraction. So for example, if we have the sequence 3, 5, 7, 9, and it goes on and on, this is an arithmetic sequence because to get the next term we always add 2. So our goal here is to try to find a formula that will tell us what the nth term of the sequence is. And what nth term means is, for example, let's say 3 is the first term, and I'm going to write that as A1. And this is just a notation of how you write the first term of an arithmetic sequence. And I think A stands for arithmetic, but you don't always have to write A. It could also, some people write T1, which stands for the first term, but I'm just going to stick with A1, but you can also use T1 if you want. So the second term of the sequence is going to be A2, the third term of the sequence is going to be A3, and the next term is going to be A4. We want to keep going until we find the nth term, or AN. And N just indicates the position in the sequence. Okay, so what we want to try to find is a formula for this AN. So I'm just going to write this out. So I have A1 equals 3. I'm just trying to derive the formula for AN right now. And A2 is equal to 5, A3 is equal to 7, and I'll write A4. A4 is equal to 9. And what we want to find is AN. So another way of writing this is, let's say we just stick to A1 instead of writing 3. This would be A1 plus 2. Because we start from 3 and we're adding 2 right here, so it's just A1 plus 2. This is going to be A1 plus 2 times 2. Because to get to 7, we're starting from 3, which is A1, and we're adding 2 twice. So 2 twice, it's just going to be 2 times 2. So the fourth sequence is going to be A1 plus 2 times 3. Because to get 9 right here, we're going to start from 3, and we're going to add 2 3 times. So then we see a pattern here. We have A1, and we all have 2 all the time, but then we always have 2 times 3, and it goes on and on. And this would just be 2 times 0, and this would just be 2 times 1. So AN is going to be A1 plus, this is always going to be 2 times 0, 1, 2, 3. So we're just going to start from 0, 1, 2, 3. And how do we indicate that with this formula? Well, we see that this is 4, and this is 3. This is 3, and this is 2. This is 2, and this is 1, this is 1, this is 0. So basically we're just subtracting 1 from this number n. So this is going to be n minus 1. So we have the formula here. AN equals A1 plus n minus 1 times 2. But what if we're not adding 2 each time? Here, we add 2 each time. That's why we've been writing 2 and 2 and 2. But what if we're adding 3, or what if we're adding 4? So we're going to make this another variable. So the number you're adding is going to stand for D, and in this case D is 2 because we're adding 2 each time, but sometimes D could be 3 or it could be 4, or it could be any number. So the formula we have now is going to be AN equals A1 plus n minus 1D. And D is a number that we add by each time. N is going to be the nth term in the sequence, and N is going to be the position of the number, and AN is going to be what the number is, or the nth term of the sequence, and A1 is going to be the first term of the sequence. So this is our formula for an arithmetic sequence. And it might be a little bit confusing right now, but then if we use this in the next problems, I think you'll understand it. So what is the 12th term of the sequence? 4, 8, 12, 16, and on. So I'm going to write the formula here. So we have AN equals A1 plus n minus 1D. So we want to find out AN because we want to know the 12th term of the sequence. And we know that n is going to be 12 because we want to find out A12, right? 12th term of the sequence. And the first term, A1, is going to be 4. And D is going to be 4 because we're going to add 4 each time. So we're just going to plug this in and we're going to solve for A12. So A12 equals 4 plus 12 minus 1 times 4. So we have 4 plus 11 times 4, which equals to 4 plus 44, which equals to 48. So the 12th term of the sequence, A12, which is the 12th term of the sequence, equals 48. So this is our answer. Okay, the next problem. How many terms are in this sequence? 8, 12, 16, all the way to 400. So we want to know how many terms are in the sequence. Because if this is A1 and this is AN, we want to find out what this N is because we want to find out how many terms are in the sequence. So we know A1 is equal to 8, we know that AN is equal to 400, and we know that D is equal to 4 because we're adding 4 each time. So I'm going to write the formula here. AN equals A1 plus N minus 1D. So we know AN is 400, A1 is 8, plus, and we don't know N, that's what we're solving for, and D is going to be 4. So then I'm just going to simplify this, and we have 400 equals 8 plus 4n minus 4. 400 equals, and 8 minus 4 is 4, so 4 plus 4n. And I'm going to subtract 4, so we have 396 equals 4n, and n is going to be 99. So that means there are 99 terms in the sequence. Okay, so this is some word problems to see some applications for arithmetic sequences. So this is a problem I got from regentsprep.org. So after knee surgery, your trainer tells you to return to your jogging program slowly. He suggests jogging for 12 minutes each day for the first week. So A1 is going to be 12. Each week thereafter, he suggests that you increase the time by 6 minutes per day. So we're going to have 12, and then the next week you're going to be running 18, and the next one you're going to be 24, and it goes on and on. How many weeks will it be before you're up to jogging 60 minutes per day? So you want to know. So AN, the last term, is going to be 60. And this is going to be the first term. So we want to know N because we want to know how many weeks or how many times we're going to add 6 each time until we get to 60. So A1 equals to 12. AN is 60, and we want to know what N is, so I'm going to make that a question mark. And D, we know we're going to add 6 each time because we're running 6 extra minutes per day. So I'm going to plug that into the formula. AN equals A1 plus N minus 1 times D. So AN is going to be 60, A1 is 12, N minus 1 times D, which is 6. So 60 equals 12 plus 6n minus 6. So we have 60 equals 6 plus 6n. And then we have 54 equals 6n. And then we have n equals 9. So it's going to be 9 weeks before the person is running 60 minutes per day. So the next problem. The theater has 20 seats in the first row of the center section. Each row behind the first row gains 3 additional seats. How many seats are in the 7th row of the center section? So the theater kind of looks like this, let's say. So this one has 20 seats, this one's going to have 23 seats, 26, 29, and we want to know what's going to be until the 7th row. So we know that A1, the first row, is going to have 20, and, So we want to know how many seats are going to be when n equals 7. So we want to know A, that's what we're looking for. So A7 is a question mark. And D, which is how much it increases by each time, it gains 3 additional seats when you go back each row. So I'm going to plug that into the formula. AN equals A1 plus N minus 1 times D. So we have A, so what we're looking for is A7. So A1 is 20 plus N minus 1, so we use like N is 7, so we have 7 minus 1 times D, which is 3. So this equals to 20 plus 6 times 3, which is equal to 20 plus 18, so 38. So that means there are 38 seats in the 7th row in the center section. Okay. So thank you for watching, and hope you enjoyed this video.